everyone, this is Vandana and you are watching 99.9 Engineering Station. So student, today we are going to start a second lecture of Engineering Thermodynamics. Before that, if you have not subscribed to my channel, subscribe it. Otherwise, you will not get any type of notification from my side. And one more important thing is that you have to follow me on Telegram, because in Telegram I used to post many important questions, numericals, PDFs, short notes and many more things. So follow me there and subscribe my YouTube channel. So without wasting time, let's get started with the lecture. In the previous lecture, we were discussed about the aim and the definition of thermodynamics, and then we discussed about the approaches, two approaches, that is microscopic and macroscopic. In the case of microscopic, we used to the concept of continuum that I already explained in the previous lecture, that we are going to consider one particular amount of volume in which the concept microscopic approach is applied. Okay, so this is about the concept of continuum. Now in this lecture I am going to discuss that the validity of concept of continuum, that in which case the concept of continuum is valid, and in which case concept of validation, concept of continuum is not valid. So in the case of, if we consider in the case of all the liquid and solid, the concept of continuum is valid. In the case of every liquid and solid, the concept of continuum is valid. But if we consider the case of gases, in the case of gases, the concept of continuum is not valid. Why? Because it is the molecules of the gases are very randomly move. It has very high velocity, that molecules move from one position to the another position. It means they could not attain any particular volume if the system is open. That's why the concept of continuum is not valid for particular gases, not valid for every gases, but it valid for particular range. What is the range and how we select that range? That is with the help of Knudsen number. And now Knudsen number is the ratio of mean free path upon characteristic dimension. Mean free path to the characteristic dimension. Now here, what is mean free path? Knudsen number is the mean free path upon characteristic dimension. Now what is mean free path? Mean free path is defined as basically it is the average distance covered by or traveled by the molecules after two successive collisions. It means, if suppose for example we have these molecules move in this direction and collide with another molecules, then it move to the third direction, that here is also again it collide with another molecules, and then after it move to any direction. Okay, तो two successive, इसके लिए दो successive कोलिजन हो गए, एक ये हो गया, एक ये हो गया, तो हम इसका एवरेज, सपोज ये डिस्टेंस हमारा y1 है, y2 है एंड ये y3 है, तो इसका एवरेज क्या होगा? मीन फ्री पाथ कैसे निकालेंगे? मीन फ्री पाथ इज द समेशन ऑफ डिस्टेंस कवर बाय द मॉलिक्यूल्स. ठीक है, तो ये इस तरीके से that's how we calculate the mean free path of the any molecules. Okay, so this is the average distance covered or traveled by the molecules after two successive collision. So, and if you talk about the characteristic dimension is the one dimension, any one dimension which of the system which is critical. ठीक है, so that's all about the Knudsen number. So what is the range? If we talk about the range of the Knudsen number, what is the range that the concept of continuum for the gas case is valid? That is, if the Knudsen number is smaller than 0.01, then only the concept of continuum for the gases is valid. Okay, so that is all about the concept of continuum and all the introduction part of the microscopic and macroscopic approach. Now we discuss some fundamental terms related to it. That is, first quickly understand what was that. That is system. First one is system. That's what is system. System is the quantity of matter or the space in the quantity of matter or region of space where our attention is focused. So that is the called as system. And after remaining system, all the portion is called surrounding. Surrounding, if we adding surrounding and the system, it is called as universe. And then we discuss about the boundary. That is, boundaries are two types, real and imaginary. And real is again divided into a two category, that is movable and fixed. What is movable and fixed type of boundary? That suppose we have a container. Suppose we have a container and this is the closed container. What will happen when it is filled with a water or any type of gas molecules and we heating it from the bottom? So what happens? See, there is no heat or mass transfer taking place from this container because all the boundaries are fixed. So this type of conditions are come into that type of condition, that is they have this type of system have fixed type of boundary. But in case of if we consider another example, like we have a cylinder and three side of the cylinder is fixed and but one side is movable, that is called piston. If it is piston and we heat it from the bottom, what will be happen? Because of heating, the molecules are expand and the piston move upward, and after some time when the heating of the molecules or randomness of the molecules is reduced, the piston is come down again. But it means this piston is movable. So in that case, the boundary that we call this type of boundary is called movable boundary. And basically all the work for so if we want to get the work from any system, so that we have at least one movable boundary in this system. What I am saying, that if we want to work from any system, we have at least one movable boundary in the system. Okay, now we talk about the imaginary system. Imaginary boundary, what was that? Suppose मैंने ऐसे करके एक पोर्शन बना लिया. ये क्या है? ये एक ऐसी बाउंड्री है जो मुझे नहीं दिख रही ना आपको दिख रही है, लेकिन मैंने एक बाउंड्री बनाई तो है. वहां से मास ट्रांसफर हो ही रहा है, यहाँ से एयर आ रही है, यहाँ से मॉलिक्यूल्स एयर के यहाँ से जा रहे हैं, तो मास ट्रांसफर तो हो ही रहा है यहाँ. लेकिन मैंने क्या एक इमेजिनरी बाउंड्री क्रिएट कर दी है. तो दैट टाइप ऑफ बाउंड्री इज कम इनटू द इमेजिनरी बाउंड्री. So this is the first type of classification. If we talk about the second type, that is classification based upon the heat. That is, first classification is adiabatic boundary, and the second one is dithermal boundary. So what is adiabatic boundary and dithermal boundary? So suppose we have a boundary which do not allow heat to move through it. That case of boundary is called adiabatic boundary. This boundary is not allow heat to move or to pass from it. And for the case of dithermal boundary, the boundary which allow the heat to pass through it. Okay, so this is the basic difference of the boundaries, like adiabatic boundary or diatomic boundary. So I think you understand it very well. Another concept is the what type of system. There are three types of system, that is open system, closed system and isolated system. In the closed system, the heat and mass transfer is not allowed. In the case of open system, only the mass transfer is allowed, heat transfer is allowed, but not mass transfer is allowed. And the case of isolated system, there is no exchange of heat and the mass transfer take place. So if we talk about the example of isolated system, so the universe is the best example for the isolated system, but it is not the exact isolation system. Or another, in the daily life we have the cello flask in which the water remain cold when till at least 10 hours, or if we put hot water in it remain hot at least 10 hours. So this is the example of systems. Now we discuss about the thermodynamics properties. So what are these properties? There are two types of properties, like intensive property and the extensive property. These properties are very important, and many of the questions in the GATE is come under this topic. So listen properly and understand properly. So let's discuss the intensive property and the extensive property. As I said earlier, that the thermodynamics properties are divided into a two category, that is extensive property and the intensive property. So let's discuss what is extensive property and intensive property. Okay, so basically the extensive property are the property which depends upon the mass and the size of the system. Which depends upon the mass and the size of the system. Whether if we talk about the intensive property, it is the independent from the mass and size of the system. Sorry, it does not depend upon the size of the system. Does not depend. While we talk about the intensive property, this type of property is independent from the mass and the size of the system. You can remember this with the I term, that in case of intensive property, I, intensive, and it is independent. Independence I, the I of the independent, both the I comes, it means it is a intensive property. So let's discuss some of the example. Before that, consider, for understanding the example better, consider this room as a system. So if we consider this room as a system, so we have some type of parameter in this room, like this is my room, and this room has some parameters like pressure, particular amount of pressure, temperature, density, molecular weight, mass. So this room has such type of property, and any type of energy, and some type of energy this room have. If we divide, for understanding the concept that it depends upon the mass and the size, so we cannot divide the mass into two parts for the case of pressure, temperature, so we divide it into a two size, that we divide this room into a two equal parts. Let's do it. If we divide this room into two parts, what will happen with the parameters, like pressure in this part is equal to the pressure in other part, like pressure is remain in the both the part of the room. So we can simply write as P for this section, pressure P for this section. Okay, if we talk about the temperature is also same in both the cases, so we can write it T and T for the both the cases. If we talk about the molecular weight, molecular mass, what will happen? The mass, molecules are divided into a two portion, then it will be half. Okay, then another parameter, that is volume. If we consider the volume is also divided in two parts, it means it will become V upon 2 and V upon 2. Okay, now the another term is, that is density. So what is density? Basically density is the mass upon volume. So in that system, in our system, that is room, what was the mass? If we divide it into a two cases, two equal parts, mass is become m by 2 and the volume is also become m by 2. It means 2 is cancel out and V upon 2, it means 2 is cancel out and we remain with a m by V, which is equal to density. It means density for both the portion will equal to the rho. Okay, that is all about it. Now we talk about the another point is that the mass. Now consider the example. What was these example? The pressure is independent of the size and mass. It means it is intensive property. Intensive property. If we consider the temperature Temperature is also independent of mass and size. It means this is intensive property. If we take the molecular weight, it is extensive property, and volume is extensive property. And if we talk about the density, energy is extensive property. Sorry, energy is also divided into two categories. That's why it is come into the extensive property. Okay, if we divide in case of density, what will happen? Mass is the extensive property and the volume is also extensive property. It means density is the ratio of two extensive property. In that case, if we have the ratio of two extensive property, it become intensive property. So you have to write out in anywhere that the ratio of any two extensive property become intensive property. One more important thing is that if we consider specific property like specific enthalpy, specific entropy, this type of properties also are intensive property. Okay, these type of properties also come into the section of intensive property. So these are very confusing if you do not understand this concept. If you have any type of confusion, then simply divide it into a two part, and analyze what is that property become half or not. So this is all about the today's lecture. I hope you understand very well. So do not forget to subscribe, share and comment down below in the comment section. So thank you and have a nice day.